Hello everyone, welcome back to my another video. In this video, we are going to learn about the Rookie polynomial, counting and non-taking Rookie placements, where we are going to understand the polynomials offering a unique way to solve in various combinational problems. Where we are going to basic definitions of that, where we are considering a chessboard, where it consists of a grid of squares, imagine a standard chessboard or a smaller sector. A rookie which we are going to consider as a chess piece, and non-attacking, which we are going to take an column grid of square in the board where the pawn cannot be attacked, which we are going to place, and the r of k, which resembles the already present grid. There is a formula for a rookie polynomial, which as defined, r of x is equals to r naught plus r1 x plus r2 x square plus so on up to rn x to the power n. Now going to the further, where we are going to consider the position which already the pawn is considered as one or non-attacking rookie, where we are going to always consider r naught is equals to one, and representing the zero rookies, the highest power of n is smaller board dimension. We are going to consider an 2 into 2 board where the zeroth rookie it is always placed in one way, and the one rookie where it can be placed in four different spots, and the two rookies can be placed in two ways diagonally. So the rookie polynomial for a 2 into 2 matrix is 1 plus 4x plus 2x to the power 2. This is illustrate the coefficient representation of distinct placements. Now we are going to take example of 3 into 3 board where r naught is always placed 1, and r2 will be placed at 9 positions, and r3 R2 can be placed at 18 positions, and R3 can be placed at 6 positions. Where the R1 represents the each rook can one there is only one pawn which we can keep in any one of the way, and when it goes to R the increase of rookies, it goes on increasing the positions. When it comes to R3, where we are going to take only combinations of three, which non-attacking sets, goes on further, where we are going to know about the disjoint subboard, where in decomposition, boards can be broken into non-overlapping sectors, to make it easier, and multiplication rule, where we are going to know about the rookie polynomials, taking the rookie polynomial formula, where r of b is equals to r of board is equals to r of board plus into board r of board 2, where the disjoint board of B is disjoint and made B1 and B2, where we are going to know join by using the formula of multiplication rule and simplification. This is a property makes complex calculation easier. Decomposition of board into disjoint subboards simplifies the calculation of the rookie polynomial of the whole board is the product of polynomials of the disjoint parts. The board decomposition example. Initially, the board is 4 into 4 with and 2 into 2 holes, and the subjoint board where we are going to remain the top 2 into 4 rectangle, and third part we are going to retain the subboard 2 as bottom 2 into 4 rectangle, where we are going to divide the 4 into 4 matrix into 2 into 4 and 2 into 4 top and bottom, where we are going to calculate it separately and combine it to form an complete board calculation. So it makes easier and moves further easier. Applications where we can see this polynomial permutation and restrictions. Restriction positions. Imagine arranging a people who were some people where some seats are often limited. Rookie analysis analog. This problem can be mapped to placing a rookie on a board. Problem solving. Rookie polynomial helps in countering a valuable arguments. Rookie polynomial is also excellent for an problem individual permutation with an resistance position. For instance, if you are arranging a people in a seat that cannot be occupied, this can be modified as a rookie polynomial on a modified board where blocked cells are simply not a part of a board. Advanced concept of a ferrule board, where the ferrule boards are an unique stair-step shape, where we are going to not take a 2 into 2 matrix or 4 into 4 matrix. We are going to utilize in a step manner, where it makes a combination of attacks or a rookie's placement easier. and it has a connective theory linking an theoretical and a symmetrical function, where the Ferrari board Ferrell board is a specific shape used for combinatory and polynomials possessing a unique properties related to the partial future dependent and insights in mathematical structures and connectory combinatory within most abstractive mathematical fields. Coming to the conclusion part, there are 3 points which we are going to discuss here. Where the rookie first coming to the first point, the powerful tool, a rookie polynomial simplifies complex counting problem, and the second, diverse applications for securing the theoretical and mathematics. And the third, the future studies, exploring the connection of graph theory and matrix performance. Rookie polynomial offers a powerful entanglement, offering opportunities to combine on problem and their utility extending beyond the basic applications in diverse fields. Further, we can study and relevant fa- uh, fascinating connections to graph theory and matrix permanent awareness to an research and problem solving. And thank you. We are going to see an theoretical solving part in this with an
Now we are going to know practically about the polynomial. As we know, a root polynomial, a form which is maybe any kind, should be placed in a board which may be 2 into 2 matrix or 3 into 3 matrix. But it should not be sidewards or downwards or upwards, making a plus symbol. The another point should not be in there so that it is non-attacking routine. Now we can place a rookie of 1 year and 1 year in the 2 into 2 matrix. Another way cannot be possible. But in 3 into 3 matrix, you are able to place more than 8 to 9 rookies in that. Going further, we are going to solve an example also. So that you will be record. I'm going to end this video. Examples of this rookie polynomial is we are going to consider a 3 into 3 matrix 1, 2, 3, 4, 5, and 6. As we as we know, the rookie polynomial formula is r of x is equals to r0 plus r1 of x plus so on up to r of n x to the power n. And we are going to see a rookie polynomial example in a practical manner here. We are going to a board of 3 to 3 matrix where we have 6 points which we are going to consider as r1 is equals to 6, where we have the we have to consider non-attacking sets which are 3. We can make it as 3 comma 5, 3 comma 6, and consider, do not forget it should not be in plus manner, as that the position of an key is here in the center. It should not have an sidewards or downwards, upwards, or any rookies possible attacking. Now, when we do, we can make it 2 comma 4, 2 comma 5, 2 comma 6. That is not possible because it is in row. Then we are going to make it as 1, 1 comma 4, 1 comma 5. At last, we have the 4 left out in the second row, which we are going to take as 4 comma 5 and 2 comma 6. Then there are no possible keys to fall into pair of 2. So we are going to take as pair of 2. Then we are going to take the previous number of outcomes, 8. Then we are going to consider for 3 keys. where we can make as 246, 246. 345 is not possible due to it is in the row. 145, 145. And another way of making is 3, 5, and 1. But after going down our system onto our course, so it's not possible. So going further, we'll get R3 as 2, and further we cannot make any combinations of 4 because it is a 3 into 3 matrix. So we are going to do our Ricci polynomial. R of x is equals to, and R naught is considered as 1 plus, where always R naught is equals to 1, we know that. So we have directly taken R2 is 6x plus R3 is, R2 is 8, sorry, R1 is 6, where we are going to take as R1x, where the formula of Ricci polynomial R of x is equals to 1 plus, which we are going to take as R naught, and R1 plus x plus, so R up to n R n plus n to the power x to power n, where R1 R naught is 1, R2 R naught is 1, R1 is 6 x plus R2 is 8, 8 to the power 8x to the power 2 plus R3 is 2 x to the power 3. The final answer is 1 plus 6x plus 8 square plus 2x cubed. This is going to solve an solution matrix. So this solution matrix is polynomial for this answer. Thank you.